You know what's scary about the space around Earth? It looks empty, it looks harmless, until you remember we live inside invisible rings of radiation that can fry hardware without leaving a mark. We call them the belts because that word sounds calm, but they're more like trapped lightning, particles held by Earth's magnetic field, circling above us day and night like a silent fence. Most days that fence has a soft edge. Satellites cross the boundary and the instruments warm up, the counters rise, and engineers shrug because that's how the sky works. Then the newest tracking pass came in and the fence wasn't soft anymore. It looked cut with a blade. A sharp radiation edge like someone took the belts and cinched them tight. And it wasn't a tiny shift you argue about in meetings, it was a sudden wall. One minute the readings were normal, the next minute the counters jumped hard in the same spot every orbit. That's when people stopped calling it space weather noise and started calling it a feature. Because noise doesn't draw clean lines in a place that is supposed to be messy. Here's the part nobody likes saying out loud: the belts didn't just move. They narrowed into a thin band, a tight ring around Earth, and the outside region went strangely quiet. Quiet, then violent, like the radiation wasn't gone, just pushed into a narrower lane. The kind of change that turned safe orbits into roulette with no warning label. At first the usual suspects were blamed: a solar storm, a shockwave, a bad calibration. Anything that keeps the story familiar and keeps the reports boring. But the timestamps ruined that comfort. The tightening didn't align with flares or storms, it aligned with one thing: the pulse windows people were already watching on 3i Atlas. Not the pretty photos, the timing. The repeating beat in its data, the same windows where its behavior looks too neat to be random. The same moments where tiny anomalies stack up. On the first overlap, everyone called it coincidence. On the second, they held their breath. On the third, the belt edge snapped into place again like it was following a schedule. Let me slow it down, because this is where it gets real. Earth's magnetic field doesn't usually tighten on command. It flexes, it wobbles, it swells with the sun's mood. So when you see a clean cinch and a clean release that repeats, you don't ask, is this dangerous? You ask, what grabs field lines without touching the planet? And that question drags you into uncomfortable territory fast. Because if the belts can be pinched, then the region that protects us can also be shaped. And shape means controlled. Now, I'm not talking about a movie beam. I'm talking about a physical squeeze. The kind you see when currents change, when plasma pressure shifts, when the field is forced to rearrange. Those are normal processes, but they don't pick neat intervals on their own. They respond to the sun, to storms, to chaotic inputs. They don't lock to a visitor's repeating clock. Which is why the next check was brutal. Different satellites, different sensors, different orbits. Same edge, same narrow band, same sudden jump right at the predicted window. That's when the phrase sharp boundary became a problem. A boundary means two regions with different rules, and in space that usually means a barrier, not just a gradient. The engineers started plotting safe corridors like air lanes, avoid the band during the window, delay the pass, shift the maneuver. It sounds small until you realize how many systems depend on timing. Navigation, comms, imaging, even power budgets. A belt shift changes charging, charging changes glitches, and glitches are how good data turns into bad decisions. And it wasn't only the belts, the magnetometers showed a subtle kink, like a muscle twitch. Nothing huge, just enough to tell you the field wasn't drifting, it was being nudged. Now ask yourself this: what kind of nudge makes a ring tighter instead of thicker? Not heat, not random turbulence, a squeeze, like pressure applied from the outside. 3i Atlas wasn't near Earth, but its path mattered. Each time it hit the next node of its route, the belts answered with the same pattern, like a ripple arriving on delay. That delay mattered too. The cinch didn't happen instantly. It arrived after the pulse, a wave traveling through the heliosphere and reaching Earth like a moving front. Once you see it as a wave, the edge stops being mystical. It becomes a compression, a moving wall of plasma pressure that shoves the belts inward and sharpens the boundary. But then you hit the next problem. Solar waves don't keep perfect time with a single object. They're broad, they smear, they drift. This one kept coming back on the same beat. So the question isn't, did 3i Atlas cause it? The question is why 3i Atlas and the belts are synced at all, and why the sync is tight enough to predict before it happens. Because prediction is the line. When you can call the window and the belt edge appears, you stop living in a world of coincidences, you start living in a world of mechanisms. And mechanisms have consequences. A narrow belt means concentrated radiation. Concentrated radiation means faster damage. It's the difference between a bruise and a burn. That's why this story isn't about one weird plot. It's about an environment change around the planet you live on, happening in repeatable windows tied to an interstellar visitor. Stay with me, because the next part is where the belt edge starts acting less like weather and more like a gate. And gates always raise the same ugly question: who gets through? When the edge turned sharp, operators stopped calling it a belt and started calling it a gate, because a gate doesn't just burn you. A gate decides what passes clean. On the first clean pass, a weather satellite clipped the boundary and nothing dramatic happened. A spike, a few resets, the kind of bruise engineers accept because space is rude. Then a small CubeSat crossed the same track during the next window, and its telemetry went flat for 12 seconds. Not dead, just silent, like its radio got swallowed. Minutes later, it came back, and the only thing it remembered was time. Power was fine, memory checks were fine, but the event log had a clean hole punched through it. That hole was the clue. Random upset spray errors everywhere. This one looked selective, like the system was forced to skip a beat and keep marching forward. Now listen carefully, because this is where timing becomes the weapon. If the belts are being squeezed into a narrow lane, then crossing that lane at the wrong moment is a test. Not a test with alarms and sirens, a quiet test, where charge builds faster, current spikes sharper, and the smallest weakness in shielding gets exposed in seconds. Engineers started comparing which spacecraft glitched and which stayed clean. Same edge, same window, different outcomes. That's what made the word gate stick. Heavier satellites with better shielding took the hit and kept talking. Lighter ones stuttered. Some cameras came back with streaks like scratched film. Some came back perfect. So the question isn't, is radiation higher? The question is why the boundary feels sharper than radiation levels alone can explain, like there's structure inside the band. Because a band can be thick and hot. This looked thin and edged. And thin edges in plasma usually mean a current sheet, a place where fields fold and snap. If you've ever seen a storm front on radar, you know the look. One clean line where calm air ends and everything changes. The belt started showing that same geometry. And the geometry kept arriving on schedule. Not the same clock as Earth's day, but the same clock as those three Atlas pulse windows people hated admitting they tracked. That's when the team stopped asking, what did the sun do? They started asking, what is this wave riding on? Because a wave that repeats needs a channel. The channel looked like Earth's magnetopause tightening, like the whole protective bubble got squeezed in a little, then relaxed, then squeezed again on the same beat. If you squeeze a balloon and hold it, the rubber thickens where you press. That's what the belts looked like, thickened into a narrow ring where particles got trapped harder. But balloons don't squeeze themselves. Something outside had to press, and that press arrived after each 3i Atlas pulse like a message that takes time to travel. So they mapped the delay. Pulse first, belt cinch later, release later, and the delay stayed within the same narrow range cycle after cycle, like a courier route. That pattern did one more thing. It pulled older mysteries into the light. Past unexplained satellite resets were replotted on the new clock, and some snapped into alignment. Not all. Enough. Enough to make the room cold because it meant this wasn't born yesterday. The beat was there before. We just didn't have the trigger to notice it. 3i Atlas didn't invent the gate. It revealed it. Like shining a flashlight across dust in a dark room and suddenly seeing the air has texture you never named. And once you see texture, you start seeing risk. A tight band of radiation is a razor you drag across an orbit. Every pass becomes a chance to lose sensors, lose time, lose trust. That's why the quiet response turned into a real change. Operators widened margins. They shifted maneuvers. They stopped scheduling delicate burns inside the window. Because the worst outcome isn't a dead satellite. The worst outcome is a wrong reading that looks clean. A sensor that survives but lies, and nobody knows it lied. Now imagine that happening to navigation. A small bias in timing, a small drift in attitude, and suddenly your safe corridor is calculated on poisoned numbers. This is why the gate idea matters. A gate is not just danger. A gate is selection. It decides which hardware keeps its story intact and which comes back with missing pages. And that leads to the next question nobody wants. If the belts can be shaped into a lane, then the same shaping can steer particles into places they don't normally reach. Lower orbits feel it first, then high inclinations, then transfer paths, then the places humans live for months at a time above the atmosphere. I'm not saying the sky became lethal overnight. I'm saying the protective map we trust started moving with a rhythm, and a moving map is how surprises happen. So the next cycles became the only thing that mattered. Not to panic, but to measure, predict the window, watch the squeeze arrive, and prove the gate is real in advance. Because once you can predict it, you can't call it noise anymore. You have to name the mechanism, and naming it is when the story stops being a glitch and becomes a chapter. Naming a mechanism starts with a map, not a pretty one, a working one. You take every pulse window and draw what Earth's magnetic bubble looked like right before the squeeze. Then you overlay what the sun was doing. Not headlines, not drama, just raw numbers. Density, speed, field direction. The stuff that decides whether space is calm or sharp. The uncomfortable result was consistent. The sun wasn't quiet, but it also wasn't commanding these edges. The squeeze arrived like a patterned front, not like a random storm. So the focus moved from the sun's mood to the space between. The highway the solar wind travels on. Because a front that repeats needs a track, not just a shove. That's when the phrase compression wall started showing up in internal notes, a traveling pressure ridge that hits Earth's shield and forces the belts inward into a tight lane. And the lane wasn't drifting around. It was sitting where it always likes to sit when the field folds a certain way, like a crease in fabric that keeps reappearing. Once you accept fabric, the next step is obvious. You look for the seam. You look for the place where the magnetic field changes state, where particles get trapped harder. They found it in the timing of the boundary itself. The edge didn't roll in gradually. It snapped into place over minutes, held, then relaxed, like a clamp tightening. A clamp is useful because it tells you the direction of force, not from the planet outward, from outside pressing inward, and pressing inward in space is done by pressure and current. So they watch the current systems, the invisible loops that run along field lines and close through the polar regions, the same loops that light auroras like nerves firing. On squeeze nights, the auroras didn't just brighten, they tightened. The oval drew in, the way a noose draws in, and it did it with the same timing as the radiation edge. That mattered because it linked the belts to the field's muscles. If the aurora pattern tightens, the whole system is under compression, not just one sensor acting up. Now the gate stopped being a belt problem. It became an Earth system mode, a temporary configuration the magnetosphere drops into, then climbs out of on a repeating schedule. And schedules are where this turns from weird into dangerous. Because once a mode is repeatable, you can be inside it on purpose or by accident, and both outcomes change planning. The teams built an advanced warning flag. When the upstream monitors saw the right field twist, they marked the next hour as a high-risk corridor for charging an upset. That flag worked too well. It predicted squeezes more often than it missed, and when something predicts the sky, you stop calling it anomaly and start calling it behavior. At that point, the attention shifted back to one ugly detail. The compressions lined up with 3i Atlas pulse windows, even when the solar wind conditions were otherwise ordinary. That alignment forced a new framing. 3i Atlas wasn't sending a storm. 3i Atlas was hitting a node, and the system answered through a channel we weren't watching before. Think of it like striking a glass. The hand is far away from the resonance point, but the resonance still appears where the glass wants to sing, not where the hand is. Earth's magnetosphere has preferred ways to ring. Certain field orientations, certain currents, certain compressions. The pulses look like someone tapping the system on its favorite note. And once you say note, you can test it. You look for harmonics, small echoes at other planets, small repeats in the same timing in places with clean measurements. That's when the Mars threads came back onto the screen, the moon orbit ripple. The same pulse windows, different planet, different geometry, same timing signature. One link is a coincidence, 2 links is a pattern, 3 is a mechanism, and the third link was sitting in archived deep space tracking data, hiding in plain sight. Not a loud spike, a thin drift in timing, precision that shows up only when you stack the same windows across years, the kind of thing you miss until you know what to ask for. Now the gate has a bigger meaning. It's not only Earth's belts got tighter, it's the medium between planets is structured enough to press on multiple systems on a clock. That's why nobody wanted to name it publicly yet. A name thing becomes a thing you must explain. And this one forces a hard admission. The map of normal space was too simple. So here's the line that matters going forward. The belts didn't just change, they responded. And once Earth can respond on schedule, the next question becomes unavoidable. What happens on the next cycle when the squeeze lands harder, the gate narrows further, and the first high-value spacecraft crosses it at the exact wrong second? The first time the gate caught something expensive, it didn't explode. It didn't burn up. It just started lying in tiny ways that only matter when you're trusting it with your life. A navigation bird crossed the band right on the marked window, and its clock slipped by microseconds. That sounds cute until you remember microseconds are distance when you're moving fast. Ground stations saw the drift, corrected, and the craft corrected back. 2 smart systems arguing politely in real time, each convinced the other one was wrong. For 12 seconds, the orbit solution forked 2 versions of reality, one where the satellite was fine and one where it was offset just enough to make everything downstream shaky. Then the belt edge tightened again, sharper than the last cycle, and the telemetry showed a spike like someone dragged a charged wire across its skin. You've heard engineers say single event upset like it's a normal thing. This didn't look like a random upset, it looked like the spacecraft took a clean hit and kept flying. The star tracker didn't crash, it blinked, it dropped a frame, then reacquired the field with the same stars, but shifted by a hair, like the sky moved underneath it. And that's the moment everyone went quiet, because when a tracker blinks at the same time clocks drift, you're not dealing with one bad sensor. You're dealing with the environment changing in a way that touches timing, charge, and light all at once, inside a window that keeps coming back like an appointment. The control room didn't say we're in danger. They said the words they always say when they're scared. Let's hold until we have more data. Holding is expensive. It means pausing maneuvers, delaying uploads, burning schedule. But nobody wanted to push a system through a gate they couldn't describe. Here's what makes the gate worse than a storm. Storms smear. They rise and fade. This edge had geometry. It had a border you could draw with a ruler. So they started treating it like a no-fly line. Not officially, quietly. They'd route passes around it, avoid sensitive operations, keep high-gain antennas asleep during the window. That works until you can't avoid it. Earth orbit is crowded, mission plans are tight, and sooner or later something must cross the lane right when the clamp tightens. The second strike was nastier because it hit a radar platform. Big power, big surfaces, big currents. The moment it crossed, the bus voltage dipped and recovered like a heartbeat. The payload kept running, but the data came down with a strange signature. A thin band of dead pixels across every frame. The same width, the same angle, like a scar. A scar is what you get when charge builds unevenly. One patch charges faster than the rest, then discharges in a snap, and the snap is invisible unless you know where to look. That's the simple version. A tight radiation lane means faster charging. Faster charging means more arcs. More arcs means more silent damage that looks like normal aging. And the gate was concentrating that risk into a time window. Not space is harsh all the time. Space is harsh right here, right now, on this beat. Now it wasn't just a belt problem. It became a planning problem for every system that assumes smooth conditions. Clocks, comms, sensors, attitude, power, anything that hates surprises. And then the gate did the thing that made people reach for older files. It shifted a little early, like it moved to meet an incoming spacecraft instead of waiting to be crossed. Not by a lot, minutes, but enough to ruin the comfort story that this is just a wave arriving and leaving on its own schedule. Because waves don't anticipate. Waves arrive when they arrive. A boundary that tightens early around traffic feels like an interaction, even if nobody says that word. Let me slow it down, because this is the line between eerie and unacceptable. A field can compress naturally, but a compressing edge usually doesn't sharpen in response to a target. So they checked the upstream monitors again. Solar wind looked ordinary, no clean shock, no obvious pressure jump, nothing that should have made the clamp bite harder. Yet it bit harder anyway, right on the pulse window tied to 3i Atlas, and it left behind a more stable lane, like the system learned the shape and held it. The next step was desperate and logical. If you can't stop the gate, you measure it from the inside. You schedule a sacrificial pass with hardened sensors and watch it close. They did it with a test platform that can take abuse. It crossed the lane at multiple angles, multiple altitudes, multiple times, and the edge behaved like a blade each time. Same border, same rapid rise, same hold, same release. A controlled experiment repeated by the sky with results clean enough to make denial feel childish. And once denial dies, the fear changes shape. It stops being, will it hurt us, and becomes, what else can it shape? Because belts are only one part of the shield. If you can pinch the belts, you can pinch the loss cone. You can steer where particles rain down. You can make polar regions louder or make quiet regions suddenly hot. You don't need to hit Earth to change Earth. You only need to change the rules of what enters and where, and the magnetosphere is the rulebook we rely on. That's why, on the 5th cycle, they quietly compared the gate windows to ground clocks. The best atomic clocks, the ones that don't forgive fantasy. They didn't see a big jump, they saw a phase wobble, tiny, repeatable, always inside the window, like time itself got a slight tremor when the clamp engaged. And if time tremors, everything that depends on time tremors too, navigation, sync, networks, power grids that align phases, systems that assume the sky is stable. Nobody announced it because you don't announce a tremor in the clock people use to measure reality. You just tighten your grip and keep measuring until you're sure. Then the next window arrived, and this time the gate didn't only tighten. It shifted latitude by a hair, placing the sharp edge under a corridor used by crew traffic. Not today, not a disaster, but the message was clear. You can't treat the lane as a fixed scar on the map anymore. It can drift, it can hunt. So the question isn't, can we avoid it? The question is whether the gate is part of a larger structure moving through the system, and Earth is just the first loud instrument. Because if this is a traveling compression pattern, the belts are the easiest place to see it, but the same pattern would pass every planet, every magnetosphere, every moon with a field. And that brings you right back to 3i Atlas. Not as a rock, not as a headline, but as the metronome. The thing whose pulse windows line up with the clamp every time. On the next predicted cycle, the upstream monitors were calm again. The sun was boring, space weather was normal, and the gate still formed like a clean cut. That's when the room stopped asking about storms and started asking about channels, about seams, about a structured medium that carries pressure like a signal, not like a gust. Stay with me, because the next part is where the gate starts showing up before the window, not after, and that's the moment you can't pretend you're only watching weather anymore. The weirdest part wasn't that the gate came back, the weirdest part is that it started arriving early, like it was already there, waiting, and the window was just when it became visible. On the first early cycle, the forecast said the squeeze should hit after the pulse, but the sharp edge formed before the pulse, then held steady like a line drawn in ink. That breaks the comfort story. A traveling wave arrives late, not early. If the boundary shows up first, it's not only a shove, it's a structure Earth is moving through. And once you say structure, you stop looking at the sun and start looking at the medium. The thin, invisible stuff between planets that we treat like empty air. Space isn't empty, but we talk like it is because empty is easy. Charged particles, fields, currents, all of it is real. But most of the time, it behaves like weather. This didn't behave like weather. It behaved like a corridor. A lane with edges that stay sharp, a lane Earth keeps intersecting, and the pulse window is the crossing point. So the next test was simple and cruel. If the gate is a standing corridor, then it should be detectable even when nothing exciting happens at the sun. They waited for an ordinary day. No big flare, no screaming alerts, just a boring upstream feed. Then they watched the belts anyway, because boring days are the best days to catch lies. The edge still formed. It tightened, held, and released with the same clean geometry. And the clock wobble returned inside the same window like a cough you can't ignore. That's when the story stopped being 3i Atlas triggers a squeeze. It became the squeeze and 3i Atlas share the same phase, like two metronomes locked to one beat. And phase lock's a dangerous word, because phase lock means repeatability. It means you can schedule around it. It also means you can schedule into it. Nobody said that second sentence out loud, but you could feel it in the way they started talking about crossing times like they were talking about a minefield. Let me slow it down, because this is where people get lost. The belts are trapped particles. The trap is Earth's magnetic field. If the field is squeezed, the trap changes shape. Changing the trap changes where particles gather, where they rain down, and how fast they charge surfaces. That's the whole chain. Nothing magical, just geometry and pressure. But geometry that repeats is the problem. Because repeating geometry means something is enforcing the shape, not just letting it drift like a loose ribbon. So they looked for enforcement. The cleanest clue was the border itself. On the early cycles, the border didn't drift in. It was already sharp, then it intensified. That already sharp state is hard to explain with a passing gust. It feels more like a sheet or a boundary layer, something stable that Earth moves into. And if it's stable, it has a map, a location, a thickness, a direction. The kind of thing you can intersect at one latitude and miss entirely at another. That's why they started pulling data from every orbit, not just the usual ones. Low, high, polar, equatorial, anything that could slice the structure from a different angle. The result was consistent and ugly. The sharp edge appeared in a band of altitudes like a ring. Not everywhere, not uniform, a specific lane that stayed put in magnetic coordinates. Magnetic coordinates are what the field uses to define up and down in space. It's the map you can't see, and this lane sat on that map like a scar. Now remember the early arrival. A scar doesn't arrive early. A scar is there. You arrive at it. That's why the timing flipped. Earth wasn't being hit. Earth was crossing. And if Earth is crossing a fixed lane, then the pulse windows aren't causes. They're markers. The moments when the crossing is clean enough to show itself in the data. That framing changes everything about 3i Atlas too. Because if 3i Atlas shares the phase, then it's not just passing by. It's moving in the same rhythm as the lane. Not following Earth. Not aiming. Just sharing a beat that seems too neat for chaos, and once you see neatness, you start counting how many systems it touches. That's when someone pulled deep space tracking from outside Earth's bubble. Signals that don't care about belts, because they're not inside them. They're just passing through space. They looked for the same tiny clock tremor in those links, a wobble in timing, a microscopic phase shift, the kind of thing you need a perfect clock to even notice. And it was there. Small, repeatable, always near the window. Not enough to break a link, but enough to say the medium itself wasn't steady. So now the gate is not only a belt phenomenon, it's a space phenomenon. A change in the air between Earth and the antennas, like the channel thickened for a moment. If you've ever heard a radio station bend during a storm, you know the vibe. The signal doesn't die, it warps. It comes back with a thin distortion you can't unhear. That's what the timing wobble felt like, a subtle bend in the path length. Like space got slightly denser in one corridor, and the corridor kept coming back. And now we can finally ask the hard question in the right way. Not what is 3i Atlas doing? The question is, what are we both moving through? Because Earth crosses the lane and 3i Atlas hits its own nodes, and the nodes line up on a beat that shows up in belts, auroras, and timing links. That's not proof of intent, it's proof of structure. A structure that exists whether anyone wants it to exist or not, and a structure that is now visible because patterns line up. So the teams did what teams always do when the world gets weird. They built a model that assumes the lane is real, and they asked it to predict the next sharp edge. The model didn't need poetry, it needed only one thing, the phase. When will Earth's magnetic coordinates cross the lane again with the same alignment? The next prediction landed 3 days out, not a guess, a specific window, a specific orbit band, a specific expect the border to be razor sharp here. They scheduled a hardened test pass. They pointed instruments at the edge, they watched the counters, and the border appeared exactly where the model said it would. That's when the fear got cleaner, not louder, cleaner. Because a predictable hazard is a controllable hazard, but it's also a real hazard you can't wave away. And if it's real, you have to ask what happens when the lane doesn't only squeeze belts. What happens when it interacts with the upper atmosphere, the place where satellites dip? Because the atmosphere is the cushion between us and space, and if the cushion gets hit by a structured pressure front, it doesn't just sparkle, it shifts. On the next cycle, drag readings nudged up. Tiny. The kind of change you normally blame on solar heating, except the sun wasn't heating. The change sat inside the same window. A tiny drag bump is not a disaster, but it's another thread that ties the corridor to more than one layer of the system, like the lane presses on the whole bubble. And that's the part that keeps people awake. A lane that can press on belts, clocks, and drag is not a local glitch. It's a mode of the environment. Now we reach the point where facts and guesses start to mix, and the smart move is to separate them cleanly in your head. Fact is simple. The belts narrowed into a thin lane. The edge went sharp, the effect repeated. The timing flipped from after to before, like Earth was crossing a fixed corridor. What we don't have is a clean cause. We don't have a button in the sun that makes a perfect line. We don't have a known storm signature that explains the phase lock. So you're left with two uncomfortable possibilities. Either we've missed a normal mechanism that can create stable corridors, or the corridor is not normal, the way we use that word. And if it's a missed normal mechanism, then we've been flying through blind geometry for years. We only got lucky because the rhythm became loud enough to see. But if it's not normal, then the question isn't about one gate around Earth. The question is how many lanes exist and whether Earth is crossing the first or the fifth. Because the belts are a visible marker. Earth has a magnetosphere, so it lights up when you press it. Other planets have fields too, and some are even louder than ours. So the next quiet step was obvious. Look at the big ones. Look for the same phase in the radio noise around Jupiter and the way its auroras tighten and loosen. If the beat shows up there too, then this isn't Earth being weird. It's the system showing you a structure that spans space, and Earth is just where you noticed it first. Stay with me, because the next part is where the corridor stops looking like a single lane and starts looking like a network, and that's when avoid it becomes a fantasy. I can continue, but I have to keep it clearly as a speculative scenario so it doesn't read like a real-world claim you're reporting as fact. I'll stay in the same tone and flow, just with that framing baked into the narration. Picture this like a controlled thought experiment. Same data style, same calm voice, same chill under the words, but we treat it as a scenario that could exist if the map of near-Earth space had hidden geometry. Because once you stop seeing the gate as a single lane, you start seeing it as a grid. A set of corridors that only show themselves when a magnetosphere lights up under pressure. Earth is loud because it has belts. Jupiter is louder because it has a giant field, brutal radiation, and auroras that act like neon signs for invisible currents. So the first place you'd look is Jupiter's radio noise. Not the pretty images, the raw hiss, the constant screaming that comes from particles whipping along field lines. In this scenario, teams stack the radio data by the same phase windows, and the hiss doesn't just rise. It sharpens like a bandpass filter clicked into place for minutes. And the aurora oval tightens too. Not brighter in a messy way, cleaner, more edged, like a ring pulled inward by a hand you never see. That's the moment the corridor idea stops being an Earth story. Because if a different magnetosphere repeats the same phase behavior, you're not watching local weather anymore. You're watching a structure in the medium, a pattern in the solar wind that isn't just turbulence, but something that can hold a shape long enough to be crossed again. Now add Saturn, not because it's stronger, but because it's delicate. Rings, plasma, a field that's smooth enough to show small deformations, like wrinkles on glass. In the scenario, the ring atmosphere responds with a subtle kink, a tiny shift in charged particle density that appears as a clean border and then relaxes on the same beat. Not enough to move rocks, enough to move currents, and in space, moving currents is how you move everything else without touching it directly. At that point, the corridor stops being a wall. It becomes a channel, something that guides pressure and field orientation the way a riverbed guides water. The scary part is the riverbed is invisible until you throw dye into it. Earth's belts are the dye, Jupiter's radio hiss is the dye, Saturn's plasma is the dye. And once you see the riverbed, you start asking where it starts, because a channel that repeats on a phase has an upstream anchor, some region where the pattern is set. In the scenario, the upstream monitors don't show a classic shock, they show a rotation, a clean twist in the magnetic field direction that arrives like a turning key. That twist is what makes magnetospheres choose a configuration. It's the difference between a soft boundary and a sharp one, between drifting belts and a clamped lane. So the channel could be nothing more than a repeating field rotation carried by the wind, a rare alignment that holds shape longer than we assumed it could. But the phase lock is what makes it hard to swallow. Random rotations don't keep time with an outsider's pulse windows across multiple cycles. That's where the scenario splits into two paths. One path says the phase is coincidence, and we only notice it because we're hunting for rhythm. The other path says the phase is real, and the rhythm is being reinforced. Not by magic, by resonance, like a swing that keeps catching the push at the same point. Resonance doesn't need intent, it needs timing. If you hit the same note in a system repeatedly, the response grows cleaner, not louder, but more structured. That would explain why the gate starts arriving early. The system learns the mode. It slips into the configuration faster, like a muscle that's trained. And trained muscles are dangerous because they react before you think. They tighten when a trigger appears, even if you didn't mean to tense up. So in this scenario, the next cycles show a drift. The corridor is no longer one lane. It's a set of parallel lanes, each one narrow, each one sharp, like comb teeth. Cross one tooth and you get charging. Cross two and you get clock wobble. Cross three and you get sensor blink, the kind of blink that leaves no obvious damage. This is where mission planning turns into choreography. Not avoid storms, avoid teeth, and teeth don't care about your calendar. Because the teeth sit in magnetic coordinates, not geographic ones. They move with the field, not the map. They drift with conditions you can't see with your eyes. In the scenario, crews start treating certain transfer times as forbidden. Not publicly, quietly, like sailors avoiding a reef nobody admits exists. And then the reef does the one thing that changes everything. It catches something in deep space, far from Earth, where belts can't be the excuse. A probe link shows the same phase wobble. Tiny, but repeatable. A bend in timing that follows the window like a shadow. That's when the corridor becomes physical in the mind. Not radiation did it. Path length changed. The medium changed. Words that make engineers stare at their own plots. Because if the medium can change, then space has texture. And texture means you can have boundaries that guide, trap, and shape without needing a planet nearby. Now you can bring 3i Atlas back in without saying it's a wizard. In the scenario, it's simply the metronome that reveals the beat. It hits a node in its root, the phase is marked, and the channel shows itself in every magnetosphere that's aligned to feel it. That's not a smoking gun, it's a map of when the system rings and how the ring looks when it's clean enough to measure. And once you have a map, you do what humans always do. You test it, you try to predict the next crossing, and you point every instrument you can at the expected tooth. In this scenario, the prediction works again. The edge appears, the belt narrows, the aurora tightens, the radio hiss sharpens, the clock wobbles by the same amount. At that moment, you don't need panic. Panic is sloppy. What you need is attention, because attention is how you catch the one cycle that doesn't release. Because a gate that releases is a hazard. A gate that holds is a boundary condition. And boundary conditions are how environments change for real. So the next question in the scenario isn't a will it hurt us? It's will it stick? Will the system lock into the mode long enough that normal becomes the exception? And if it can stick, the last layer of comfort disappears, because you're no longer planning around windows, you're living inside a reshaped shield. Stay with me, because the next part is where the corridor starts leaving a residual imprint, like the belts don't fully relax after the window, and that's when the gate stops being an event and becomes a setting. The first clue that the gate was turning into a setting was subtle. After the window ended, the belts relaxed, but not all the way. A thin ridge stayed behind like a crease. At first it looked like drift. Engineers hate drift because it never looks guilty. It just sits in your graphs and dares you to blame it on noise or aging. But the ridge stayed in the same magnetic place. Not the same place over cities, the same place over field lines. The map shifted with the planet, the ridge shifted with the field. That meant the system wasn't just getting squeezed and released. It was being nudged into a new shape, then allowed to cool, but not allowed to reset. On the next cycle, the ridge thickened. The sharp edge returned faster, held longer, and when it let go, the belts didn't go back to baseline. They stepped down like stairs. You can handle storms, you can schedule around storms. What you can't handle is a new baseline. Because a new baseline rewrites every safe margin you ever trusted. Operators started seeing it in mundane places. A satellite that used to survive a polar pass clean now came back with a small attitude jitter and a faint smear on the sensor. Not a failure, a whisper. The kind of whisper that becomes a scream 6 months later when the same component has taken 100 tiny hits. That's how slow damage works. It doesn't announce itself. It accumulates like dust, and a narrow radiation lane is a dust storm you cross twice a day. So they began to ask a different question. Not when is the window. The question became, is the window leaving residue? Because residue means the corridor is sticky. Sticky means the medium is not just passing by. It means something in the environment is holding charge, holding pressure, holding a configuration for longer than it should. And if it can hold near Earth, it can hold elsewhere too. You start to imagine corridors that persist between planets, like invisible tracks that only show up when you cross them. Now the timing gets even uglier. If the gate is leaving residue, then the next squeeze does not start from zero. It starts from a preloaded state, and that makes edges sharper. Sharper edges mean faster charging. Faster charging means more arc risk. More arc risk means more silent lies and sensors, more missing pages and logs. This is when people stop caring about why it happens and start caring about how to live with it, because missions don't pause just because the sky got complicated. They built new flight rules, no delicate burns inside the window, no high gain pointing through the lane, no crew traffic when the clamp is predicted to bite. Those rules bought time, but they also exposed a truth. The lane was drifting in magnetic latitude by a hair, the kind of drift that turns a safe corridor into a trap. A trap is what you call a hazard that moves. A hazard that stays fixed is a wall. A wall is manageable. A trap is what hunts you while you pretend it doesn't. So they watched the drift, day to day, cycle to cycle. The ridge would slide a fraction, always small, always enough to force a replan if you were honest. Then the drag data came back again. Tiny bumps in atmospheric density at the same phase. The atmosphere is a soft layer, but it has moods, and its moods showed the beat. That matters because the atmosphere is where low orbits live. If density pulses in rhythm, orbits decay in rhythm. You don't crash, but you spend fuel you didn't budget. Fuel is life. Fuel is margin. Fuel is the difference between we can wait this out and we have to do something now. In the middle of all this, the pulse windows kept landing like clockwork. The metronome never missed, even when the sun was boring, even when upstream data was bland. That made the corridor feel less like weather and more like infrastructure, like a rail line in a place we assumed had no tracks. Now the next move is always the same. You try to probe the lane directly. You send a hardened platform, you cross at different angles, you measure gradients. But gradients were not the story was the edge. The edge rose like a wall, held, and fell, and the wall's location and magnetic coordinates stayed stubborn. That stubbornness is what makes people start whispering about network. One lane is plausible. A set of lanes parallel, repeating, and phase-locked feels too clean. If it's a network, it has nodes. Places where lanes intersect, and intersections are where systems behave oddly because you're stacking pressure on pressure. So they looked for intersection signatures, short windows where charging spikes were double, where timing wobble was stronger, where the aurora tightened into an almost perfect ring. They found a few, not many, enough to say the corridor has hotspots, places where the squeeze is cleaner and the edge is sharper. Now you can predict more than a window. You can predict a bad window and a worse window, and once you can rank windows, you've admitted the structure is real. This is where the story turns practical. If you can predict, you can also test avoidance. You shift an orbit a little, you change local time of crossing, you see if the hit softens. Sometimes it did, sometimes it didn't. That inconsistency is its own nightmare because it means the lane is not just a fixed ring, it has texture inside the ring. Texture inside the ring means microstructures, smaller edges, small current sheets that can bite one spacecraft and miss another by minutes. That's why the safest phrase in the room became, don't overfit. Don't trust one model too much because a model that fails once will fail when it matters most. Still, the residue kept building. Over weeks, baseline belt intensity looked slightly higher in a thin arc. Not everywhere, a specific arc, like a bruise that won't fade. And bruises don't fade when the pressure never stops. They fade when the system recovers. Recovery requires time with no squeeze. The metronome wasn't giving time. At that point, the corridor becomes more than a hazard. It becomes a new climate, a recurring squeeze that slowly reshapes what normal orbit means. And a new climate forces a bigger question. If Earth is crossing one lane, how many lanes exist around the Sun, and how often have we crossed them without knowing? We only see lanes when a system lights up. Earth lights up with belts. Jupiter lights up with radio. Mars lights up with subtle drift. The lane could be there all along. So the next fear is simple. We didn't discover a new thing. We discovered a new way to notice an old thing. And old things don't care that we just learned their name. That's why the last step is the hardest. You stop treating the lane as an event to ride out, and you start treating it as a feature you must map like a coastline. Because coastlines move, they erode, they bite, and if you build too close, you lose what you built. Stay close, because the next part is where the mapping reveals something worse than a ring. It reveals a spiral, and spirals don't just sit, they pull. So the coastline map didn't end up looking like a ring at all. Once you plot enough crossings in magnetic coordinates, the boundary points stop clustering into a circle. They start lining up into a curve, a sweeping arc that keeps bending as the days pass, like the same structure is rotating past us while Earth keeps intersecting it. That curve is when the word spiral appears, and everybody pretends they didn't say it. Because spirals in space sound like mythology until you remember the sun already writes spirals. The solar wind blows outward, but the sun rotates, so the magnetic field gets dragged into a curved pattern, like water from a spinning sprinkler painting the air. That's the simple picture. A spiral means the field isn't just out there. It has lanes, it has preferred directions, it has arms you can cross again and again. In this scenario, the gate lane sits on one of those arms. Not perfectly, but close enough that Earth meets it on a repeating rhythm as the sun turns. And suddenly the timing flips make sense. Sometimes the arm reaches Earth first, sometimes Earth reaches the arm first, depending on how the geometry lines up that week. That's why the edge can show up early. You weren't waiting for a wave to arrive. You were rolling into an arm that was already there, like driving into fog. Now bring 3i Atlas into the same geometry and you get the cleanest chill in the whole story. It isn't causing the spiral. It's moving on a path that tags it. Every pulse window becomes a marker, like a lighthouse flash that tells you, right now, this arm is being lit up somewhere else in the system too. You don't need intent for that. You only need alignment. Two objects crossing the same structured medium on a rhythm that repeats often enough to look like design. And here's the nasty part about spirals. They don't just sit like walls, they guide flow. A spiral arm can steer charged particles the way a river channel steers water. So a belt squeeze becomes easier to imagine. The arm presses the magnetosphere, the trap tightens, particles concentrate, the edge sharpens into a thin, hot boundary. Once you see it that way, the network stops being parallel rings. It becomes braided strands along a spiral arm, little filaments that can bite one spacecraft and miss the next. That explains the inconsistency without killing the pattern. Same lane, different teeth. Same arm, different microstructures. Same beat, different damage. In this scenario, the mapping team start ranking crossings by how deep into the arm Earth goes. Shallow crossings make a soft edge. Deep crossings make the blade. And deep crossings leave residue. Not because the belts want to stay tight, but because repeated compression builds a new distribution of particles that takes longer to leak away. That's how a temporary gate becomes a climate. The arm keeps coming back, and every return starts from a slightly preloaded state, like pushing a swing that never fully stops. Now the prediction game gets sharper. It's no longer a window tomorrow. It's a deeper crossing in 5 days, the kind that puts the sharp edge under critical corridors. And critical corridors exist whether you talk about them or not. Crew routes, high-value comms, timing links that hold networks together, things you don't want blinking. This is where the clock wobble matters most. In the scenario, the wobble grows a hair on deep crossings, not enough to break time, but enough to bend assumptions. Systems that rely on perfect sync start disagreeing more often. Not catastrophic, just irritating. The kind of irritation that turns into an outage when it hits the wrong moment. And because it's a spiral, the wrong moment is predictable. The arm has phase. The sun's rotation gives it rhythm. The belt edge gives it a visible signature. So the teams do the only sane thing, they try to see the arm directly, outside Earth's bubble, using particle monitors and radio links that cut through the same medium. They don't see a glowing ribbon, they see a pattern of small shifts, slight changes in particle direction, slight changes in field orientation, tiny bends in signal path length. Each change is boring alone. Stacked by phase, it becomes a fingerprint. And once you have a fingerprint, you can start asking where the arm's densest segment sits. In the scenario, it lines up suspiciously close to the places we already treat as special, like the upstream region where monitors sit and wait for solar wind to hit them first. That's another quiet horror. The arm isn't hiding in deep space. It's brushing the same neighborhood where we think we're doing safe early warning. And if early warning is inside the structure, then early warning becomes part of the structure. You're measuring the wave from inside the wave, and your baseline is biased. That's how the story stays calm while it gets darker. Nobody says apocalypse. They say calibration, and drift, and margin, and we need another month of data. But the month of data keeps pointing the same way. The arm is there. The belt squeeze is the local symptom. The clock wobble is the subtle symptom. The drag bumps are the soft symptom. Now the spiral earns its name. It doesn't just appear on maps, it behaves like it pulls events into alignment, like it makes separate systems ring in the same key. Auroras tighten, radio hiss sharpens, belts cinch, timing bends. Different instruments, different physics layers, one rhythm threading through them. And the scariest thing about a rhythm is how quickly humans learn to rely on it. Once you can predict the gate, you start planning around it like it's permanent. That's fine until the rhythm changes, until the arm shifts phase by a day, until the deep crossing arrives early, until a crew transfer is scheduled on yesterday's geometry. In this scenario, the first near miss is mundane. A planned maneuver gets delayed because the safe window is suddenly not safe, and the flight team sees the edge form too soon. They burn extra fuel to wait it out. Nothing breaks, nobody dies, but everyone understands what just happened. The map can move faster than the paperwork. And then the next cycle brings the worst pairing you can imagine in a quiet story. A deep crossing happens on the same day a normal solar disturbance shows up. Not a monster storm, just a standard shove. But if the arm is already compressing the magnetosphere, a standard shove can become a hard clamp. That's when the gate stops being a thin lane and becomes a wider region with multiple sharp edges, like the structure thickened for hours instead of minutes. In that thicker window, the belts don't just tighten, they churn. Particle populations shift faster, charging becomes uneven, the safe corridors become a patchwork of risk. And patchwork is deadly to planning, because you can avoid a wall. You can't avoid a quilt of teeth when you don't know which tooth bites your spacecraft's weak spot. This is where the story tries to split facts from guesses, even inside the monologue. The measured part is the repeatability. The measured part is the sharp edge and the phase. The unmeasured part is what the arm really is at the micro level. Current sheet filaments, pressure ridges, field folds, call it what you want. We don't get to touch it. So the only honest move is to keep mapping, keep predicting, keep testing. Treat it like a coastline you can't see, only feel when you sail too close. And once you accept coastline, you accept something else too. Coastlines have bays and capes. They have choke points where currents accelerate and hazards concentrate. In this scenario, Earth is approaching one of those choke points, a season where geometry will make crossings deeper, more frequent, and harder to route around. That's why the last line of every internal note sounds the same. Monitor the next window, compare to the model, update the phase. Don't trust last week's map. Because if the spiral is real in this scenario, then what we're calling a gate is just one place, where the spiral touches us hard enough to leave a mark. And if it can leave a mark here, it can leave marks elsewhere, on other planets, on probes, on links, on anything that assumes space is smooth. So the next question isn't does the gate exist? The next question is where the spiral's next arm intersects something we care about, and whether we'll notice before it clamps. Stay with me, because the next part is where the map predicts a crossing that lines up with a major mission corridor. And the gate doesn't just tighten, it splits into two edges.